Is there anyone did not get it? Because there were one or two handwritten addresses, which I couldn't really read. So if anyone didn't get it, or if anyone is new today, could you come at the end of the class and we'll write down your address again, and I will send it you, and you get the next one. Okay. So, is that too dark for you, or are you going to sleep? No. One at the back? I don't know. Aha. That seems okay. Okay. So, yesterday, but first of all, I apologize. Israel has given me the most wonderful cold virus. So I'm struggling a little. I hope it'll still be okay for the duration of the lecture. So yesterday, we saw two distinct philosophical points of view about the difference between humans and other animals. On the one hand, we had the exceptionalist point of view, which says that humans are radically different. There is some qualitative difference between humans and other animals. Humans have a soul, or maybe only humans are conscious, or maybe only humans can engage in rational thought. Other animals can't do any of these things. This is what I called the exceptionalist position. And I contrasted that with an anti-exceptionalist Darwinian position. The Darwinian position, as I put it, is that humans are just another animal, that the difference between humans and other animals are similar to the differences which separate any other set of species. If it's a closely related animal, the differences are small. If it's a distantly related animal, the distances are large. And therefore, the main differences between humans and other animals are quantitative, not qualitative. Saying we're different doesn't imply... saying that they are quantitative doesn't mean we're the same. There are definitely things humans can do which other animals can't do. There are definitely things which humans can do which other animals can't do so well. But we can, in the anti-exceptionalist position, we can explain human capabilities as an improvement, as an evolution over capabilities which are also present in other animals. I showed both arguments, and I said we have to look at what are the actual differences. So the next three lectures, the lecture today and two more, are about the differences. Today I'm going to talk about making tools. I'm going to talk about abstract thought. Tomorrow I'm going to be talking about language and about culture. Next week, next Sunday, I'm going to be talking about the actual human brain, human neuroanatomy, and human genetics. We're going to find there's some differences in all of these, but we're going to examine the quality of those differences. And then, because we're scientists, we're interested in explanation. So we're interested in what were the factors which allowed humans to develop these capabilities? And I think interestingly, just as interestingly, what are the factors which prevented or which weren't present in other animals? So why didn't chimpanzees develop in a way similar to humans? Why didn't gorillas? Why didn't orangutans? So that is the theme. That is the theme we're basically treating. Now, I also put up I put up yesterday slides showing a whole list of putative things where humans have been alleged to be grossly different from other animals. And there is no way in 6 lectures I can go through all of these. I could do one lecture on each, and even that would be still relatively superficial. So we have to make a selection. And I've selected a small subset of things where humans are alleged to be different, which are, I believe, very important. And the first 2 in this list are today. The first half of the lecture is going to be about making tools, and the second half of the lecture is going to be about abstract thought. Now, humans are classically tool makers and tool users. You're writing with a pen, that is a tool. on a piece of paper, which is another sort of tool, which was manufactured in a paper factory, and the pen was manufactured in another factory using plastic, which came from another factory again. This is humans. And it's very important to realize this is not just modern humans. As long as we have an archaeological record of humans, they've been using tools. They might have been stone scrapers, stone knives, stone axes. Later on we get metal tools. Later on we get all our modern things. But in any society, however primitive we look at, whether we look at it today as an anthropologist, or whether we look at it through the remains which archaeologists can find, we always find tools. So it's very definite that humans, all human society, however so-called primitive, all human societies make and use tools. And when I was a kid at school, I was told that, of course, this is what makes us human. Other animals do not make tools. This is what I was told when I was about 15 years old. And if this was true, we'd have a very simple explanation for human success. We have bows and arrows, we have nuclear bombs, we have cars. This makes us successful. It's completely false, because we're going to see that other animals do use tools. There's a woman you may... Yes? Sorry? Yeah, what do I mean by... what I mean is that is the belief that history is driven by the history of technology. So, for instance, there's a series of books in the historical literature suggesting that the Huns learnt how to ride horses with stirrups. Because they could have stirrups, they could hold a lance. Because they had a lance, they were better horsemen than their opponents. Therefore, they spread that Mongol culture across Europe and across Asia. That's not technological determinism. It's an example of technological determinism. Someone invented fire, they knocked out everybody else, and so on and so forth. There's a very famous woman called Jane Goodall. Have you all heard? Have some of you heard? She's a wonderful woman. She worked in Africa, and she was one of the first people who, instead of looking at animals in zoos, actually went to the natural habitat of the animals and observed what the animals did in their normal lives. So an animal who's in a zoo, and this is a very important point for everything which is coming up, an animal in a zoo or in a lab is a deeply unnatural animal. It's not in its normal environment. It doesn't have its normal social relationships. Quite often it's an orphan. It's not been brought up normally by its parents. Sometimes it has, but very often it hasn't. And it doesn't run the normal set of dangers which animals have. It's fed regularly. It doesn't have to look for food. It's a completely abnormal animal. So Jane Goodall said, I am going to look at chimpanzees as they actually are. She went and she developed the techniques of observing chimpanzees, which is not trivial. We talked about it yesterday with Christoph Bosch, who is one of her successors. You have to go in the forest, and you have to habituate to the chimpanzees. In other words, the first thing a chimpanzee will do if it sees a human is run away. And if it runs away, you can't observe it. So the chimpanzees have to get used to you. You have to blend into the background. Then you have to learn to be able to recognize all the chimpanzees so you can work out what they're doing. And then you have to learn very careful quantitative skills of observation. So you can say, how often do they do this? How often do they do that? Is this a behavior we never have? Is this a behavior we have rarely? Is this a behavior we have commonly? Anyway, from the point of view of this lecture, she discovered very early on. What's happened? Oh, we're not interested in that. Sorry, I apologize. That's just the Mac. She discovered that they used sticks. They did something called termite fishing. They would break off a stick from a tree. They would strip it of leaves. So there really was a little bit of manipulation involved. Take off all the leaves, take off all the small branches. Then they would dip it into a termite mound, all the termites would jump on the stick, they would pull out the stick, and then with their hand they would take off the termites and eat them. This was a fundamental behavior for them. They also discovered they would use sticks as weapons, not really to fight with, but they would wave the sticks in the ground, wave the sticks in the air to threaten another chimpanzee, or to threaten a predator, or to threaten a human who was coming too close. They could sometimes throw sticks at people. So this is what Jane Goodall discovered. Later, Christoph Bosch, the colleague I was talking about yesterday, learnt that they all, in some chimpanzee societies, but not in all, only in some places, the chimpanzees actually use stone tools. There's a very nutritious nut they have called cooler nuts. They will take one big stone, an anvil, and put it on the floor. They will take a second stone, and they will put the nut on the anvil, and they will pound it to break open the nut so you get to the kernel, which is the nutritious part. This is a very deliberate behavior, and they noticed that mothers would spend a very long time, years, teaching this skill to their offspring. And it means you have to choose stones of the right height and weight. Quite often you have to transport the stones to the place where you're going to use them. They've been observed transporting stones for up to 500 meters. You have to have the nuts, you have to choose the right nuts, and so on. Other studies, more recent still, have shown chimpanzees actually making spears. You get a stick. It's not a two-part spear. It's a one-part spear. You get a stick. With your teeth, you gnaw it off to make a sharp end, and then they stick this into tree trunks to spear bush babies. I should add, in that study, it was shown that only the inefficient chimpanzees did it. The efficient ones just chased the bush bunnies out and caught them. But the young ones and the females who weren't strong and weren't fast did this. Later, we've seen that orangutans do the same. Later, we've seen capuchin monkeys doing the same. So at least among the primates, tool use is pretty common. Later, we're going to see it's not just primates. Yes? I think that is a terminological problem. You could say they are, yes. I think the difference here is this is not a genetically determined behavior. So one of the very interesting things that Bosch found was that you only get this behavior in some parts of the forest. And you get parts of the forest where the nuts are still there. So there are cooler nuts, there are stones, but the chimpanzees don't do it. So this is a culturally transmitted behavior. And we've also seen that at times, I'm going to show examples later on, you can introduce a behavior to a tribe of monkeys, and it will learn the behavior. In Japan, I think I have a video at some stage, monkeys were fed sweet potatoes, and they were living by the sea. They learned that if they dipped the sweet potato in the sea, they could have a nice salty flavor, and this was more fun. Salty chips are better than non-salty chips. And first of all, 1 or 2 monkeys developed this, and over 30 years it spread through the whole tribe. So these are, I think, nest building, as in birds, is genetically determined. Any bird will do it without learning from anybody. This is a cultural skill. But yes, in some definitions, why not call it a tool, by all means. Now, these tool building skills can be quite interesting. And I'm going to show you a video now of a chimpanzee, bonobo. Bonobos is a sub-branch of chimpanzees, called Kansi, who is actually a language-trained animal. So later on in a different lecture, we're going to see Kansi learning to actually speak. But in this, we're seeing Kansi who makes stone tools for a purpose. So in the experiment we're going to see, there's a wooden box in which the lid is held tight by a rope. Kansi has to cut the rope to get to a reward. And you don't see it in the film, but he's been shown how to do this. There's been no training, no reinforcement, but the experimenter has demonstrated how you can do this. And to cut the rope, he needs a knife. And for a knife, you have to make a knife. And he's been taught how to chip stones to make a knife. And what you will see is, I think, will demonstrate just about any of us will be convinced that when he does this, this is an extremely deliberate behavior. There is absolutely nothing random about it. Sorry?
Kanzi and Dan Benicia have achieved a completely different level of intellectual functioning than the other members of their family. Here, we see this manifest in part in Kanzi's ability to make a tool. Stone tool manufacture, demonstrated to Kanzi by the anthropologist Nick Toth, is another competency which Kanzi acquired observationally. Here, he attempts to make a sharp flake so that he can cut through a thick rope which holds a box shut. The box contains bananas.
That is really
Kanzi's first
behavior.
flake is too dull, so he discards it and opts to make a better one.
True patience. And we get our banana. Now, there's an important point to note here. He was trained in the sense that it was observational learning. He was shown how it's done. So this proves two things, one positive and one negative. The positive one is it wasn't standard reinforcement training. It's not the training you use to train a circus animal. So the circus animal, you will train little bit by little bit, and you will give a reward for every stage of the training. And it's known that you can train animals to do extremely complicated things this way. Kanzi was not trained that way, and that is good. But there's a negative point too. This is not a behavior which has nothing similar has ever been observed in the wild. No one has ever observed a stone knife in the wild in the hands of a chimpanzee. So this was a behavior which was introduced by the experimenter. So this seems to suggest, this is my gloss on it, not the papers. My gloss on this is that the chimpanzees do have the intelligence to learn this kind of behavior, but there's something in chimpanzee society which prevents the society from inventing it itself. I can't prove that, but this is my argument. Yeah?
Isn't it like a winner-takes-all sort of thing? I mean, once we started developing tools, we got the option to develop more tools. I mean,
definitely, yes. Very much.
It's just luck. Maybe they could have been rulers of this world if only they would have invented the knife for us.
Conceivably, yes.
So what exactly would a chimp in the wild use a knife for? I mean, it's fair for.
Yeah, that's a good question. That's a good question too. But for instance, chimpanzees are carnivores, and cutting meat is a really useful thing to be able to do. So I could see a use for a knife.
If your teeth are sharp enough to do that for you, then why would you need a knife?
True, but why did humans develop knives? Maybe for the same reason. Our teeth then, actually we come later where I'm going to talk about fire and cooking. Our teeth, at the time we developed fire, were about as good as chimpanzee teeth. And then our molars have become, since we've invented fire, our molars have actually become smaller and smaller, probably because we no longer need to chop off raw meat. So, which is chicken and which is egg? There was another question, yeah.
Did they try to teach other monkeys by mimicking this monkey's behavior?
On this particular task, to my knowledge, no. But on other tasks we're going to hear about, yes.
So they are able to
Yeah.
teach each other.
But again, it's the initiation and the spread. Now, we've seen primates, and we all have this sort of prejudice that primates are clever. We know, it's not a prejudice, it's a fact. Primates are clever. But it's important to know that tool use is not limited just to primates. We've seen dolphins, which will break off sponges from the seafloor and use them to probe underneath rocks for fish. And again, this is a cultural behavior. It's only one population of dolphins which has ever been observed to do this. It's not a general behavior of all dolphins. We've seen elephants, which can use sticks to throw at keepers or at other animals. They can also use sticks to scratch their body. We've seen crows, which get leaves and actually shape the leaves to use, again, as probes to get insects out of tree holes. So there's a broad range of animals can use tools, and some of them can do it in an exceptionally clever way. I'm going to show you in a second a video of a crow. Crows are really super intelligent. And the crows, obviously, in the wild, never meet wire. Wire is not something which exists in the crow's environment. In the experiment I'm going to show you, there's a metal tube, glass tube, sorry. Inside the tube, there is a worm, and crows are really keen on worms. And by the side of the tube, there are some wires. Now, before these experiments take place, the crows are allowed to play with wires. So they know what a wire is, they know it can bend and this sort of thing. But here, there is no observational learning. No one has taught the crow in any way how to get the worm out of the tube. Now, if you watch this video, you'll see how the crow does it. The crow, not the chrome. Chrome is my browser. How the crow does it. And I think it's pretty impressive. So, first of all, gets a wire and tries to pull out the worm with the wire. It doesn't work. Because you try just a straight wire, you try pulling out a worm, you can't do it either. So he tries a bit. Gives up. Thinks. And now, what's he doing? He looks, checks. Now we bend the wire round the glass tube. And we have a hook. And there we have food. Now, I think that is pretty clever. And again, not trained about the use of hooks. No previous experience with hooks. So that rather suggests that the crow is doing some sort of mental simulation in his head, thinking, how on earth can I do this? When he's doing a scientific experiment. He's testing to see if his hypothesis about how to pick out worms can actually work. So anyone who sees this sort of video and can claim that only humans make tools and only and non-human animals can't, I think has some real problems with the argument. Yeah.
Crows also use cars to crash nuts. I mean, they throw nuts in the middle of the street like cars crash them, and it just...
I've read that, yeah. I don't know it, but I've read it somewhere, yeah.
And so it is kind of use of tools.
Yeah.
Novel tools.
Yeah.
There are still two very unique properties, I think, that one can observe for all of these examples. One is that animals, if they use tools, it's always for a very immediate purpose.
Sure.
So either it's food or something that one can achieve now. The second is that humans still seem like the only species where one individual can create a tool for another. So you started with the pen or the paper example, so there are factories where one organism creates tools for another organism.
Well, even without, in some societies, even without money, but yes.
Or whatever, but the thing is that it's not limited to a use of the same individual that creates a tool, and it can pass from one end to another. And if you think of that, if each one of us was obliged to create his own tool.
Robinson Crusoe, yeah.
Yeah, so probably they were not that complicated, you know?
I totally agree with, well, I certainly agree with the second point. So the second point, I think, is that the tools, human tools, are a social creation. So one person creates, another person even elaborates on it, uses one tool to make another tool. At the end of this chain, we have the tools we actually use. That's one. The first point you made was sort of tools for immediate use. I think that's also largely true. But later on in this lecture, when I talk about abstract thought, I'm going to talk about planning. And I am going to show that at least to some extent, and at least in one, non-human animals do plan, and at least in one case I'm going to show you, they actually made a tool for future use. But I agree this is ecologically very rare, and I think 95% of the time what you say is true. So the fact I've got those two exceptions doesn't really spoil what you're saying. Yeah.
Say that I think it's not special, what you just mentioned, it's not special to tools. It's a question of what kind of reward would work on a human and on other animals. And what you just said is that people can work for a reward that is not necessarily immediate, or that is social, or that is symbolic, like money.
Sure, sure.
People do work for the reward. They don't work for nothing. But they, for the crow, it's really easy to understand what was the reward.
Getting the worm. Yeah.
Yeah, and for people it might be.
So I think, yeah, okay. So I think humans have a more.
For future use.
Right.
So that's not immediate reward.
In those animals, you would expect that in order to find this, they would do whatever they can to find the food and then to fight it. So.
But I also think that in most sort of non-advanced in inverted commas cultures, most of the technology is for food, dwelling, heat, defense, sort of fairly immediate goals. I think there's relatively little is very long term. Though of course then you make rice paddies and things which are longer term. So again, what you're saying obviously has some truth to it.
I'm not saying that people are special in their rewards. I'm just saying that
Yeah.
tools is not a special case of this case of either they have immediate or non-immediate.
Yeah, okay, that's fair. And I think these non-immediate rewards are, again, a cultural thing. But culture, we have no money without culture. I can't invent money on my own. There has to be at least two of us. And a lot, and sort of social gratification, people telling me I've been good, I've been altruist, I've helped the tribe, all that is, again, a cultural thing. So that gets back to the sort of cultural thesis which I'm putting throughout these lectures. You
Just you said now that in less developed cultures you find things that are more immediate.
Yeah.
As you said yesterday, it will be very hard to find any kind of culture without any kind of art, for example, music, and these are not things that have any immediate.
Touche. You win a point.
No, actually,
It's true.
I mean,
Well, you can get pleasure out of it, but
let's see.
I think that we might be imposing our modern sense of art and music on those cultures, and we shouldn't jump to the conclusion that paintings from the primitive humans are functional artists, not serve that kind of need or other.
it's true. It doesn't serve the sort of eating purpose or immediate self-defense.
It might be a way to teach new members.
True, or to get the spirits to behave properly, or
Social connection.
yeah.
Not immediate. It's not food or defense or something you need now.
But other animals have society as
In
well.
order to be effective in defense, you need a good group communication. And one way to strengthen communication and know like how other people work and feel with you is to be, for example, in rhythm with each other, which
Yeah,
doesn't make
I
necessarily
agree.
music.
It's just
It's
more
just
complicated.
slightly further removed.
Yeah.
I think that's a fair point. You know, the worm, you have a sort of seconds of gratification, not minutes, not days. And being in rhythm with each other can help me in the war with the other tribe next week, but it's not quite as immediate. So I take that point. I think that's fine. Let's carry on because I have my own set of differences between human and non-human tools. So humans manufacture tools in multiple steps. The pen and the ballpoint pen, classical example. There's many steps to making a ballpoint pen. To our knowledge, we've never seen a non-human animal, create a tool in multiple steps. Similarly, humans make tools with multiple pieces. We call them composite tools. Virtually every tool you ever use has multiple pieces. Even if it's only an axe, it has a handle and it has the cutting edge. And maybe it has some rope around the handle so you can grip it better. To our knowledge, we've never yet met a non-human animal which makes tools in multiple pieces. It's always a single thing. You take it from nature, you modify it a bit, you sharpen it, you strip it off, you clean it, and then you use it. But it's not this sort of, it doesn't have any of the complexity of human tools. Now, there's a guy called Oswald who writes extremely boring books. I recommend you not to read them, but they are actually very useful. He wanted to quantify complexity in different societies, both animal societies and human societies. So he invented what he called a techno-unit. A techno-unit is a single object which you can get. You get something from nature and you shape it and you've got your object. He gives a better definition than that. But so a stick, you strip the leaves off the stick. That's a techno-object. You get a vine, you cut it off the tree. That's a techno-object. You combine the techno-objects to create what he called a substituent, I think. That's the name. Anyway, an object used for getting food. He just studied food gathering technology or hunting technology. So you combine these techno-units to get a tool. And he counted for lots of different societies how many different tools they had. He wasn't interested in small variants. All bows and arrows are bows and arrows, unless there's something technically different with them. How many different classes of tool they had, and how many techno-units went into each one. And what he found was that in all the so-called primitive societies he studied, the range of these tools was extremely large. You had tens and tens of different categories of tool, and each one could often contain 5, 10, 15 different techno-units. So the difference between humans and other animals was pretty large. Because in normal, if you go to chimpanzees, you will find that they usually have 1 or 2 tools they use, and they always consist of a single techno-unit. And I'd add, they're very rarely of great ecological importance for the animal. Like if you take away our tools, we're going to die. I can't even get back to my hotel tonight. So I need my tools, otherwise I'm in deep trouble. And we could never sustain our current human populations without tools. We would really be exterminated. Whereas for most animals, the tools are an extra. There's 1 or 2 exceptions. For chimpanzees, it's actually this sort of nut cracking, honey extraction, termite fishing is actually quite important for them. It probably gives them 20-30% of their calories. So this is beginning to be important. But it never has, in any animal species we know about, the importance of tools for humans. Now, yes.
That doesn't have to be a cause. I mean, we become accustomed to living with tools, but that doesn't mean that if we had no tools, we wouldn't be able to survive as humans.
I would argue that we couldn't survive with current population levels. We might be able to form a small tribe somewhere and survive.
Yeah, but we wouldn't reach this population size
without
tools. So
yeah.
Right. It would be exactly that. The tools allow us to live the way we do.
The tools allow us.
No, but I'm talking about basically the human. If a human was thrown into the wild somewhere with nothing, well, a community of humans was thrown somewhere in the wild with nothing, no tools or anything, they would learn. They would somehow manage to survive. I don't know. You don't know that.
Our physical build is not fit for survival without tools. Whereas, for example, a chimpanzee, if you throw it into the wild,
even our molars are no good for chewing raw meat. You know, we have some real problems.
Right.
I think we, 1 or 2 of us, a few survivalists, you throw them out in the wild. If they're lucky, they might survive. I think most of us would be in deep problems. Okay. Now, is this a matter of ability? So, the same guys who trained Kansi to do that tool thing looked at tools in 3 different places. First of all, they trained several chimpanzees to do the tool using task, to make stone flakes, just like we saw Kansi doing in the video a few minutes ago. Then they trained modern humans to do it. I'm sure they got students, and I'm sure they paid them a very small fee to spend hours and hours making stone flakes. And then they found a very large assembly of stone flakes at an Ethiopian site called Gomi, made by Homo erectus. So we're talking about 2.5. It was actually a bit prior to Homo erectus. It's near 2.5 million years ago. The flakes. And then this is another extremely boring paper, which you should only read really if you intend to write about this for my essay, because I tried to read it again this morning. It really is sleep-worthy. But they measured every conceivable about the tools which these subjects made, the modern humans, the chimpanzees, and the ancient humans. How big were they? How much did they weigh? What were the materials they preferred? How sharp were they? How many got broken before they became complete? And they had 42 different measurements. And they looked. First thing they found was that there is a gap. The modern and the ancient humans clustered fairly well together. Whichever measure you took, they were reasonably close, which means that humans have been making tools for a very long time. The bonobos didn't do badly at all. They made quite effective tools, but on a lot of things they were different. You can't say better or worse, but they were really different. Heavier, less sharp, blah, 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 blah. Why? A lot of it appears was probably not cognitive at all, but the motor system of the bonobo is very, very different from the motor system of the human. They found, for instance, that bonobos just couldn't get human velocity when they were moving the stone. They were clapping one stone against another. They just can't do it as fast. They observed this. And this changes the sort of flakes they made. So actually they didn't show that the modern humans were better, but they did show that they were different. And they didn't find anything in the differences which can be clearly attributed to cognition. They found a lot of differences which could be clearly attributed to muscle strength. The bonobos were less precise but stronger. So basically, this paper, if you read it, for me, the paper gives no really clear conclusions. But it doesn't show an obvious, clear human cognitive superiority. Now, I talked about.
Sorry. You mentioned that the bonobos were stronger but less precise.
Yeah.
So why would it be important for humans to be more precise at the cost of strength?
Possibly. I don't. This is pure speculation. I have no idea. But speculating, the better tools we have, maybe the less the strength we need, and the more we can use our tools.
Right. So then we have to start with making tools, and then as we have tools, we become less strong because we have tools.
I think that's reasonable. Yeah.
But it's again a chicken and egg problem.
Sure. So I think I think everything we're going to be talking about is a chicken and egg problem. There's always some improvement takes place, which enables further improvements later.
But it still leaves the question of why it didn't occur in other animals.
It does indeed. I'm going to come to that, and I'm going to try and answer that question, but not yet. Yes.
You just said that there were no differences in cognition.
No, I said there was no clear. We have.
Differences testify on the difference in cognition, but it's not motoricity.
So I didn't understand it. Yeah.
So you said that there was no clear difference in cognition in this task. So I'm just wondering that it might be a kind of a floor effect, such that if you will enable more substance or something, if you will enable the subject to create, you just mentioned techno units. So if you will have the option to create an axe or something from
then the humans would definitely do better.
So
I'm not saying
that's just a floor effect because the task is too simple to show a cognitive
this could be. It's possible.
But according to what we just said, it's sure. Like if you give more options, then humans for sure will use it. Well,
Sure. That's fair. Yeah.
And also the most basic cognitive need here is to invent it, and people invented it, not economics.
Also true. That's also true, and that's very much linked to what I'm going to be saying later. So I talked about Oswald's measures of technical complexity. It's given me the slide gives me the word I've forgotten, which is subsystem, which just means a type of tool, and the techno units. This is Oswald's formal definition of what he means by a techno unit. So the interesting thing is when he applies this. So what I see here is I scanned this. It's an extract from his book, which is so ancient they didn't have it. It's not on Google. Which explains the poor quality here. He's just documenting the various technologies. This is a small part of it. The various technologies used by Inuits, that is Eskimos. And there's a huge list. So you have medicines for treating abnormal body conditions. We have body cure and adornment, including grooming aids and adornments, combing devices, ritual forms associated with religious activities and or spiritual beings, shrouds, charms, masks, drums, tools like adze, drill, knives, scrapers, striker light, converters, bone crusher, frying pan, lamp, and it goes on and on and on. So that is the typical case of a human culture. And we are different. This is a sign. You couldn't make a list like that for chimpanzees. And people like Bosch, who are real pro-chimpanzees fans, he would love to make a list like that. He hasn't made it because it can't be done. He's really tried. He can't. Now, I'm now going to come to an interesting case where humans didn't do it. This is an exception to the rule. You go, Oswald went to many different societies and he makes lists like this for all of them. But there is one exception. There's actually a few exceptions in the world, but this is the earliest one quoted in the literature, which is Tasmanian aborigines. These are aborigines off the Australian mainland in Tasmania, and basically when Westerners came there in the 19th century, they were surprised to find that these aborigines basically had no culture. So, or no, not true, had no tools, no technology at all. They lived by the sea, and they no longer had fishing nets. They no longer had fishing hooks. They basically couldn't catch fish except with their hands, which is not an efficient way of doing it. They had
no longer.
Sorry?
What do you mean by no longer?
I mean what I say, and I'm going to say in a minute. They had no boats, so they couldn't travel. Yes?
Were the fish levels there anything like that with the near Cape Cod in the Americas? For the Americans that live there, did they basically catch fish with your hands very, very easily?
I seriously don't. I just don't know. I've not been there. But what I do know, I'm going to say something about the surrounding cultures in America, so I don't know the answer to that question. They'd lost the art of fishing. They basically didn't cook. They'd lost everything. They had no serious weapons of any kind. Now, what did they have which was special to them? They were a very small population, less than 1,000, and they were isolated for as much as 8,000 years from any of the cultures around them. And all the cultures around them had Inuit-style cultures. They all had rich technologies. They all had fishing nets. They all had boats and so on. And actually going and looking archaeologically, they found that so did the Tasmanian aborigines. But slowly over time, individual technologies got lost. So you have boats for a certain period, and then you don't have boats anymore. You have fishing nets for a certain period, then you don't have them anymore. And at the period they were observed, this is now an extinct people, so we can't observe them today. When they were observed, they'd lost everything. Now a man called Heinrich, who I don't know, but I'd love to know, Heinrich, I'd love to know because he's been an inspiration for a lot of the stuff I'm going to be teaching in this course, suggested that the Tasmanians did have all the technologies. They were just like all the other peoples around them. But the technologies gradually got lost. And he suggests they get lost by a sort of series of very natural human processes, but which can only happen in small populations. So, only one guy knows how to make fish hooks. He dies. And he dies without a son. He doesn't transmit it to anybody. We've lost fish hooks. There's a bad period where some raw material is missing because there's bad weather or something. The population is so small, the memory of how to use that material gets lost. Things get transmitted inaccurately from father to son. So gradually the technology becomes less effective, and so on. So he made a mathematical model showing that how in small populations, but not in big populations, technology can gradually get impoverished. And he claims this is what happened with the Tasmanians. He can't prove it, but it's a suggestive and interesting idea. This is his basic equations. He's saying that you can have variable success because of experiments, errors, bad memory, bad luck. If you have a big enough population, by his equations, then you will get cumulative cultural evolution. Gradually, the population will innovate, the innovations will spread through the population, and they will sum up. So your technology gets richer. But below a certain size of population, you get which is very rare because most human populations are bigger than that. The Tasmanians are a rare exception. Below that size, you start actually losing technology. And this is the essence of some of the theory I'm going to be putting forward later. So, yes?
Couldn't it just be that they obviously could survive without the use of these things, so they weren't elementary for their sustainability? Wouldn't that be a better explanation? I mean,
but they weren't necessary. But I think I think most people prefer eating a lot to eating a little, prefer being warm to being cold. So it's true they managed to survive. This is obviously true because they were observed. But they might have gained something that their population didn't grow. They never managed to colonize anywhere else.
but
that explains how they survived, but I don't think it explains the loss of. This could be true for any human society. In other human societies, it hasn't happened. We haven't lost our technology.
Maybe they haven't survived.
We've survived, but we've also increased our technological complexity. We've seen that in most of the primitive societies we're talking about, technological complexity is quite large.
No,
so why did only they lose it?
What I mean is that you fit your abilities to the challenges you face. And if you don't fit, if they were able, I mean, also circular, but if they were able to survive, maybe they didn't need all this stuff. If, for example, they were not an island, but surrounded by different tribes, and they had to fight and survive,
they might have kept weapons.
Yeah. Then maybe it would look different. But since they managed to survive, then I mean, I agree circular, but
it's slightly circular. I think the problem with that idea is I'm sure there's lots of human communities which could have survived with low technology, but which nonetheless improved their technology. Like, are we going to say that the only human group on the planet which could have survived without technology are these ones?
No, the rest didn't survive. The rest really needed in some way. And so
that's a pretty brave argument, though. Because I'm sure there are some pretty friendly environments on the planet where I'm sure you could survive. Like there's environments where chimpanzees survive with no technology. So
isolated from other communities.
Yeah, they have wars with other communities too. But,
And the lack of predators.
So I can't hear you.
Not only their isolation, maybe it's possible that the lack of predators, they're very convenient.
Okay, they have no predators. I think they seriously have no predators. That's true. So that took away the need for some weapons. But it was probably reasonably warm, and food was probably. They probably had some fruit and things to eat. Yeah.
No, just going to say that the reason there weren't any predators, basically they just managed to wipe them out very, very quickly. So.
Or they were on an island, so if they wipe them out once, you're finished. You don't have to do it time and time again.
Yeah, no, same thing in America.
Yeah. So this leads us towards the my hypothesis number one for this course, which is that humans have unique cognitive capabilities when they live in groups. We can do things when we are in a group. And what has given us our technology is important to us. What has given it us is cumulative cultural evolution within social groups. And many other features of human cognition are actually adaptations to living in a group. And I have a quote here from Tomasello, who's not my favorite psychologist, but on this we agree. And he's answering, I think, the point one of you made just a few minutes ago. He says that if you've got a human child on a desert island, and somehow the child managed to keep itself alive until adulthood, its skills and its cognition would not be much better than those of a modern great ape. Because what makes the child different from a modern great ape is primarily the fact that he's brought up in society. Now, what I'm going to suggest in these first few lectures are all evidence of plausibility in my ideas. They are not proof, they don't claim to be proof. They're just suggesting where the ideas can come from and giving a little bit of ideas that it could be true. Later on in lectures 5 and 6, I'm going to try and show how we could possibly prove this. But I'm not going to prove it conclusively. I wish I could. Yes? Was someone else asking something? Okay, let's carry on. So this is the first half of this lecture, which is about tools. not really disconnected. It's about abstract thought. And abstract thought, cognitive psychologists, it may be what the cognitive psychologist actually calls cognition. It's the ability, I'm going to define it, as the ability to make a representation of the outside world and to manipulate that representation for some useful purpose. And this gives me flexibility. It means if I have this abstract thought ability, it means I can resolve problems which I'm not genetically predisposed to solve. So I may have an instinct which says if you see food, eat it. If I see my mother's breast, suck it. That's an instinct. I don't need cognition for that. But if I see something which has never appeared in my environment before, like an iPhone, I can learn to do that too. And I can learn to use the iPhone via cognition. And one very early example was, I don't know, have you ever read about Kohler? Kohler was a zoologist and a psychologist who worked in Berlin Zoo in the 1920s. And he had a very famous experiment, which we see here. I've not got a video of this, unfortunately. Or rather, I did find a video, but it was so awful I can't project it. So you've got a chimpanzee, and you put him in a room, and there is a banana hanging from a string in the middle of the room, outside of the reach of the chimpanzee. And there's also some wooden crates in the middle of the room. And the chimpanzee has a strong motivation to go and get the banana. And Kohler sort of observed that the chimpanzee would sit in the corner and think, rather like you think before you do an exam, and just think, and then would walk into the center, would immediately take the crates, pile them up, get the banana. So fairly obviously, or at least the intuition was, that the chimpanzee had created a mental representation of the situation. In his head, he thought about what he could do to find a solution to the problem. When he found something which worked in his imagination, cognition, then he actually applied to the real world, which is cognition. So this is a sort of abstract thought. And there are huge numbers of different kinds of abstract thought. This is basically the same list I showed yesterday. Different authors give different lists. I'm just going to focus on 4. One is the difference between making the abstract difference between saying these two things are the same and these two things are different. Second one is categorization. The third one, I'm going to make 5, not 4, I apologize. Transitive inference, which I'll define in a minute. Analogical thinking. And planning, or mental time travel. And I'm going to look at the way in which cognitive psychologists have looked at these things. I'm going to look at evidence. Some experiments I show are going to show surprising ideas that non-human animals can do these things. I'm also going to show experiments by cognitive psychologists suggesting they can't do these things. And I'm going to see some of the weaknesses in those experiments, which I don't really believe. So here I'm going to show another video, this time of pigeons. Now, you would think that pigeons are not particularly intelligent animals. They don't have a lot of cognitive ability. It's not the first animal you think of when you think of cognition. But what's this? Let's watch it if I can make it go. Oh, sorry. I can't make it go. I have a thing gets in the way.
Professor John Pearce of Cardiff University in Wales examines the mind of the humble pigeon. The pigeon learns that pecking at pictures of trees brings food, while pecking other pictures does not. Food. No food. Food. No food. The pigeon learns the 30 pictures of trees that mean food. Now the critical part of the test. Professor Pierce gives the pigeon a new set of images. To recognize this picture that it's never seen before, the pigeon must have a concept of trees in its head. So do pigeons have concepts? The answer is yes. The pigeon compares this picture with its mental concept of a tree and correctly rejects the fern. To further test the pigeon's understanding of concepts, scientists showed them pictures by Picasso and Monet. They quickly learned that only Picasso meant food. But could they form a concept of Picasso's painting style? The scientists presented the pigeons with pictures they hadn't seen before. They pecked at the new Picasso and rejected the Monet. Matisse's style is more like Picasso's than Monet's, so he got pecked. Art students often confuse Matisse and Picasso too. It seems that pigeons do have concepts and rather similar to our own. Could their minds really work like ours? To test that, Professor Pierce has given his pigeons and his students the same problems.
So what I want to do in today's practical is to give you a feel for the sort of experiments I've been doing with my pigeons, and what I want you to do, in fact, is to solve, or try to solve, some of the problems that I've given my pigeons. What I'm going to do is I'm going to show you a set of patterns on these television screens. Some of the patterns will be followed by a tone, and some will be followed by nothing.
The test is to predict which pattern is followed by a tone, and which is not. Join the students and the pigeons and try and work it out for yourself. Is this followed by a tone? What about this? And finally, this pattern. How did you do compared to the students and the pigeons? The pigeon may know a Picasso from a Monet, but it can't solve this test. It pecks hopefully at all the patterns.
Okay, and so on. He also did the tests with the Picasso and the Monet, and the pigeons and the students got the same, statistically indistinguishable scores. Of course, they were American students. Here, I'm sure that it would be different. But basically, it shows that pigeons do rather well. Let's look at something different. Same and different. So a man called Oden in 1990 got infant chimpanzees, and you give them, this is a thing you often do with infants, you give them two stimuli where the first is the same, the second is the same as the first, and you give them two stimuli where they're different. And we know that both infant chimpanzees and infant children will gaze longer when they see something new. So if they can perceptually detect something new, they will gaze longer, and the chimpanzees, the infant chimpanzees, did indeed gaze longer. In other experiments, we had adult chimpanzees were shown pictures which were both belonging to cats, but chimpanzees, gorillas, tigers, fish. Again, they could use a symbol to say whether two things were a tiger and a cat, which is different, a tiger and a gorilla, which is different, a gorilla and a gorilla, which is the same. So the chimpanzees could make the same difference distinction with a very high, they got very, very good scores. Yes?
Was it the exact same picture?
No. No, it was categorically the same. So it was two different pictures of a gorilla, two different pictures of a tiger. So that's quite clever. That's showing relational similarity. You can do other ones too. In this experiment here, you got 16 pictures in a frame, and they could either all be the same or they could be different. This was again done with pigeons, and they had to click on one symbol if they were all the same, and one symbol if they were different. The pigeons did this extremely well too, but there is a but. This was something where we actually found a real difference between the pigeons and humans. Because when it was 16, the pigeons scored and the humans, they both scored close to 100%. There was no difference. But if you reduced the number, the humans continued to score 100%. amazingly, the pigeons, if there were just a very small number of pictures in the frame, could not do it. They started scrolling as if it was random. So this is a sign that although, yes, they can do categories, and yes, they can do same and different, they must be using some different sort of strategy for doing it. So yes, non-human animals do have some very cool abilities, but they're not exactly equivalent to ours. I'll give you another example, not on the slides. Counting. We can show that a huge number of animals and human infants can count to 3. Many, many different species. But humans can count precisely way beyond 3. You can count to any number you like. Non-human animals counting beyond 3, you get sort of Faber's law. So they can detect big differences. If you detect the difference between 9 and 3, they can do it. But the difference between 9 and 8, you get a logarithmic fall-off in precision. And this is probably, we believe, but it's not proven, we believe this is because humans use some sort of symbolic counting ability, a cultural ability, to distinguish the numbers beyond 3. And there is at least one culture, the piranha in the Amazon, where the man called Everett, who studied them, claims, though it's a very controversial claim, I'm not sure it's true, but he claims they can't count beyond 3. So this, in that culture particularly, this ability has never developed. I have another nice film for you, if I can click it. Now we have a parrot. Alex. This is quite long, so I'm probably going to interrupt you.
Alex, what matter?
Whoa!
That's right. How many?
2.
That's right. You're a good
Wanna
boy.
go back?
No,
Wanna go
sweetie.
back?
No, you can't go back yet. You got.
You want some water?
All right. Do you want some water, or are you just asking to interrupt? You're just asking to interrupt. I know you.
Go back?
I know you. Okay. Look. What color bigger? What color bigger?
Green.
Green. Oh, you're a good
back.
boy. Okay, Alex, look what I got for you. Hey, look. Look at all these neat toys. Look. Hey, look, can you tell me, on the tray, how many green blocks? Green blocks.
2.
Good. Parrot. 2. Green block. 2. Good.
We'll see some more Alex tomorrow when we talk about language. Alex was a language-trained parrot. She has a he, I think it's a he, has a vocabulary of about 100, and can do categories of shape, of material, of size, and can count. Again, this is not, parrots are not renowned for having huge brains. Alex was trained for 40 years by a professor called who basically did very little else with her life except training 3 or 4 parrots. And she published enormously on these parrots, you'll see in the bibliography. But basically the parrots got extremely high scores on all these tests. Basically they get virtually everything right on whatever test they do. Yes?
Were they always tested by the same person?
No, Clever Hands, it's not a Clever Hands effect, they've been tested by other people, but it has to be someone they're familiar with somehow. Because the testing paradigm, they have a competition, they have 2 people, and when they're being trained, one person communicates to the other person and the parrot observes. It doesn't work if it's someone completely new. But there are, if you read the papers, there's a lot of controls to make sure it's not Clever Hands. Clever Hands, does everyone know who Clever Hands is? Yeah, okay. Clever Hands was a famous horse in the early 1900s, it was a circus act, and its trainer would ask the horse sort of, how old is your grandmother? And she would say 95. He would ask the horse to do simple arithmetic, multiply, add, and so on. And the horse would always reply correctly by stamping its foot. And it was discovered that the horse, possibly the trainer was in good faith, but the horse was reading subtle body language of the trainer. And the trainer would show with his body language when the horse had got to the right count and stop. And so this is called the Clever Hands effect, because what the horse was good at was at reading the signs of its trainer. It wasn't good at doing arithmetic. So now if you do experiments with animals, you have to be very careful to not have a Hans effect. Let's get to another one, which looks, at least at first sight, as though it's more favourable to humans. So, one of the things was, can non-human animals have a concept of folk physics? In other words, can it have a basic idea of concepts like gravity? So, in this experiment, it's called the trap tube. It was done by an Italian called Alberghi. You have a tube here, and it has a trap, which can be either facing downwards or facing upwards. This is a hole in the bottom of the tube. You stick an object in the tube, and it's obviously an attractive object, like food. And the test animal, a monkey, can stick a stick in the tube to poke the object out. Now, if you have the object, you see it on figure A at the top. If you poke from my left-hand side, it's going to fall into the trap, and so you don't get your food. If you poke from the other side, it's going to go out, and you're going to be okay. So they gave this problem to the animals and let them see how often they poked from the two sides. And the first thing was, do they understand how to avoid the trap? The answer is yes. So the animals would learn to always poke from the right-hand side here. So yes, they could do that. But then they modified the experiment. They said, we'll turn the tube round so the trap is facing upwards. Therefore, there's no further risk of the object falling down into the trap. Therefore, the theoretical prediction was that if they understand gravity, if they understand how the trap works, they will poke equal numbers of times from left and from right. It doesn't make any difference. These were animals who had not done the first task, so they're starting from scratch. This didn't work. They discovered that the animals still liked poking from the right. The conclusion of this Alberghi, which was hyper-published, really famous result, was that they have no concept of gravity. This can be contested, as a man called Silver did a few years later. So, what did Silver do? He got the same, he took exactly the same experiment, and he replicated it with humans, adult humans. And he discovered that the adult humans, too, always poked from the right-hand side of the tube. And why? Well, no one, in the design of the task, no one had told the chimpanzees, or they were monkeys, I think, macaques. No one had ever told the monkeys it had to be efficient. No one had told them to do the easiest way. And both the chimpanzees and the monkeys were choosing the safest way. Because if you poked from the right, it didn't matter which way the tube was. It would always work. And that way we always get our M&M or the grape or whatever is being offered. If we poke from the left, sometimes it works, sometimes it doesn't. Well, that's not an easy way of doing things. So if I just want to do something in the cognitively simplest way possible, if I poke from the right, I will always work. And they did this thing both with real tubes. They also did it with drawings. So they just gave people drawings of the apparatus and asked them what to do. But the humans systematically replicated the same behavior they'd observed with the monkeys. So the difference was less big than they thought.
In the original experiment, they didn't put it half of the time in each side of the trap?
No, but
they always put it on the...
I think they inverted it, yeah, but it's always the far end. They didn't say right and left, they said far end. So sometimes they have the food on the other side.
No, but in different repetitions or different trials with the same tube.
To be honest, I can't remember. You'd have to read the paper, which is in the bibliography. Yeah.
Sounds like there's a problem here trying to check monkeys with human instruments.
I'll come to that. I'm going to talk about that in a second. So I'll interrupt you because I'm going to talk very soon about about the difference between monkey and human experiments. So I'll just interrupt that for a second. But before we do that, I'm coming in about 5 or 6 slides at a time. I just want to show you another crow experiment. Again, done with no training at all. Again, we have a glass tube. It's the same group. Glass tube, water in it this time, and there is a worm floating on top of the water, which you can't see because it's low. So we have our crow. Sees worm. Then what do we do? Looks around, inspects, thinks. Now, we put some stones down there. And what does the crow? That doesn't take a lot of thinking, does it? Not trained, not reinforced on this one. So we're Archimedes. We use Archimedes' principle. We displace the water. And in other experiments I'm not showing here, they gave it sawdust. It's not interested in putting sawdust into the water. Won't do it. Won't even try. They gave it stones of different sizes, and it would always put the right size stones in. So not too much, not too little. They would put up the sequence of stones which gave you an optimal response. So this is pretty cool. More abstract thinking about tools. I'm going to go to a third thing, so I'm a bit behind my schedule. I would if I could find it. But third thing, I'm going to come back to differences between animal and human experiments. I'm not finished on that. There's a man called Sudendorf, who I seriously don't like, but never mind. He's writing, I don't know him personally, who claims that only humans can do what he calls mental time travel. Because only humans have nostalgia, but more importantly, only humans can think about the future. He claims this is a unique human ability and that other animals can't have it. Well, not really true. We can see straight away that you can do short-term experiments, like experiments over seconds, where pigeons can learn to respond to sequences of shapes on screen. So they sort of learn the sequence 1, 2, 3, 4, 5, and if you swap numbers 2 and 3, they have to do some thinking, and you can see the response times go down. So they're doing some sort of manipulation there. Suggests they're updating a plan. But more to the point, we've got some really good experiments with jays. Jays are a sort of crow, again, whereby you train them for food, and you put some food in different they can move food to different compartments, say where they're going to cache the food, and you can see that, and you can train them so they know that one day they're going to have breakfast, they're going to be fed, another day they're not, and when they know that there's a non-breakfast day coming, they cache food for breakfast in the breakfast cage. When they know there's a non-breakfast day coming, they don't bother. If it's food which is perishable, they cache it more than if it's food that is non-perishable. So it seems that these crows are really doing some planning. And we have a lot of anecdotal reports, well, both experimental and anecdotal, about apes. So you get your chimpanzees, you teach them, you show them a task they can do to get some food, but you train them, they're going to be put in an isolation cage before they do the task, so they know it. And you can do this for an hour, 2 hours. They've done it for up to 14 hours. The ape knows it's going to go into the isolation cage. Before it goes, waiting room they call it, their nice euphemism. Before they go into the waiting room, they're offered a choice of tools. And they tend to pick the right tools, even when there is a 14-hour delay between when they pick the tool and when they do the task. So it appears that they have some sort of planning ability. We also have two rather nice reports which are anecdotal. They're not serious scientific studies, though they're by serious authors, Ospat again. One is in a zoo in Germany. There was this nasty chimpanzee which was discovered that he really hated visitors. You know, it's all these people taking photos and not giving you food. It's prohibited. They're Germans, so they obey the rules. You get the visitors and they're just gawping and taking photographs and making a nuisance of themselves. The chimpanzee would spend all evening collecting stones and And when the visitors would come, the chimpanzee would have a great fun throwing stones at the visitors and watching the visitors scatter. The caching was done the evening before. The visitors were the next day, and it would do this systematically every day. And when the keepers tried to remove stones and sort of make it very difficult, it would find new ways of getting material to throw at visitors. So that was one good one. Another very recent publication about orangutans. Apparently, orangutans, when they finish their evening travel during the day, will orient in a certain direction and make a cry, which can be heard across the forest for a long way. And the direction in which they do this, apparently, according to the study by Carol Scheich, who's in Zurich, apparently signals their direction of travel for the next day. So they are signaling to other orangutans where they can meet next day. And they worked out an algorithm from the direction in which they made this cry. The experimenters could work out which way the orangutan was going next day, which obviously to signal that, you have to have planned it as well. So we have both anecdotal and experimental evidence for planning. And now let's get onto a little bit of theory. Steven Pinker, who I said yesterday was not my favorite psychologist, but he really emphasizes human reasoning. He thinks that whenever we make decisions, we spend a lot of our time reasoning about the best things to do. But there is a lot of psychological evidence that this is really rather a rare human behavior. And most of the time, we take snap decisions very, very fast, using heuristics which we somehow developed either individually or from our culture. So, the fact that chimpanzees don't do this very much is not a huge difference compared to humans. This is the argument. The argument is that humans too, if you make an exception for university professors and students and philosophers, but normal humans, most of the time, do very well, thank you, while using relatively little symbolic logic. Now I'd like to go back to the point which I think you raised earlier about human and non-human comparisons, because there really are some big problems here. And the real question is, if I do the same experiment with humans and non-humans, or at least what I think is it really the same experiment? So, very often, for instance, there's a lot of experiments, I haven't quoted many of them, I will quote more in our next lectures, where you compare infant chimpanzees and infant humans. But the infant chimpanzee has been brought up usually in a zoo. The infant human has been brought up by a mother and father. Nearly always, in the chimpanzee experiment, the chimpanzee is in a cage. If I try and say I'm going to put the human infant in a cage before the experiment, the ethics board is really going to say no. So I'm not allowed to do that. Nearly always when you do the human experiment, the human infant's parent is really close by to comfort the human infant. Nearly always when you do the chimpanzee experiment, the parent is not there at all. Sometimes it's an orphan and the parent isn't even known. And then you have a second difficulty, which is that the chimpanzee experiments, chimpanzees are rare and expensive. Nearly always your ends are incredibly small. You will do the experiment with 3, 4, 5 chimpanzees, and you get no idea of the inter-individual variation among the chimpanzees. And in fact, we see this. If you saw the Kansi training experiment, the one with the cutting the rope, that was great. What I didn't tell you was they tried to train several other chimpanzees, and they failed. So if we really want to know what a species does, it's no good just picking one of them. So what we do depends on our upbringing. If I take one of you, you are not typical of the human race. But just as importantly, if I take one chimpanzee, particularly one chimpanzee in a zoo, that chimpanzee is not typical of the chimpanzee species either. So you would need to study large numbers of chimpanzees in different conditions, large numbers of humans in different And for practical reasons, in the cognitive psychology lab, that is incredibly difficult. No one has ever done experiments with hundreds of chimpanzees. It's just not practical. Yeah?
Also, cognitive psychologists usually do experiments on psychology students, right?
Oh, this is the famous paper about being weird. Yeah, something like 90, there's a paper by, can you remind me? Heinrich again, I think. It's the same man who did the Tasmanian aboriginees, who says that 95% of experiments in cognitive psychology are done on male, white, psychology experiments between the age of 20 and 25. So this is a deeply untypical population. And this is a paper we really should read. It's one of the Bibles. You must read this paper. It's in the bibliography. It's in India. And he goes on. He does lots of psychological benchmarks in which he shows that the performance of these white male psychology students is deeply, deeply untypical of the performance you get in world populations. So he's gone to lots of sort of primitive, inverted commas, societies. It's not even typical of older humans. You know, so he says psychology students are weird, which means Western, economic, Western, educated, industrialized, rich, and democratic. And none of those conditions are typical of the rest of the world. So that's absolutely true. So we've seen differences between humans and other animals, both in terms of tools. There are real differences. Human tools are more complicated. And in terms of abstract thought, there are some differences. Some of the things we've seen, they're really sort of peak performance, but a lot of it you can't always get. And very often the learning is very slow. I've shown some examples where it's not, but these are real examples of the propagandist for animal intelligence. I can show you other things which are less strong in favor of the animals. And we've seen there are some real methodological differences in making these comparisons. So, in the next lecture, I'm going to talk about two things which most people really do believe are exclusive to humans. The first one is language. I'm going to talk about speech. I'm going to talk about semantics, the human's ability to assign meaning to words and symbols and to have lots of them. I'm going to talk about syntax, the human's ability to combine words into sentences which have a meaning. And I'm going to talk about the social and cultural preconditions for language. What sort of culture does language emerge in? I'm going to give you a couple of examples where language has emerged from scratch in populations which didn't have language. Human populations. And I'm going to talk about culture. I'm going to talk about narrow definitions of culture, as in high culture, and broader definitions of culture. I'm going to talk about culture in non-human animals. And I'm going to talk about various cultural prerequisites for culture. There are, or cognitive prerequisites. According to some psychologists, I don't always agree with, you need a special social intelligence. You need a theory of mind. You need shared intentionality. You need an ability for altruism. You need deliberate teaching from one member of the community to another. All these things, according to social psychologists, don't exist in non-human animals. As you might have guessed, I'm going to show experiments in which they do exist. But that is for tomorrow. That's enough for today. Do you have any questions?
I do two questions. First of all, about the point we just discussed before, I think there is still one crucial point that you didn't mention, and that many times, as we Nathan said last year, things are being measured in human eyes.
Yeah.
Now, in order to try and understand if a chimpanzee understands or not gravitation, you should check it in its environment. I mean, maybe check if the grip is stronger when it's higher above ground. Then you'd be able to say that it has some kind of concept.
This is what Christoph Bosch and Jane Goodall before him said. He said the proofs you should get by observational studies. Now, this is a huge debate. The laboratory people say observational studies have no controls. It's incredibly hard to do an experiment in the wild. Therefore, the Tomasellos of this world, Fulvinellis of this world will say that the observational stuff is anecdotal. It's very rare to get real data. But the observational people will answer that we have real numbers. We've looked at things many, many times. We have observations of behaviors, like, for instance, altruism, we've seen many times in different circumstances, and the case studies add up to make a real case. If you want to read about this, I would really recommend a book. You don't even have to read all of it. It's a book by Christoph Bosch. It's written in 2012, Oxford University Press. It's called Wild Cultures. And he will make very strongly the case that you're making. He is a deep, deep believer that the only studies which count are wild studies.
I think the point he's making, though, is that you can make an ecological test. It doesn't have to be in the wild.
You
It
can
has to
create
be.
environment.
But you have to create so much environment. Like, for instance, you have to the subject would have to be brought up in a natural environment, so it has to come from the wild. If a subject has been brought up in a zoo, it's no longer a natural subject. Yeah. And you can't bring it from the wild for ethical reasons. That is absolutely prohibited. You're not allowed to capture chimpanzees for experiments. That's absolutely off. In fact, it's really amusing if you this is just anecdotal. Some modern experiments with monkeys and chimpanzees in the wild, they will write, all the monkeys gave their consent to participate in this study and were free to abandon, or participated freely in the study and could abandon the study at any time, and many did. So these are usually studies with some sort of very benign thing where you get a reward if you do something. You come and play on the experimental apparatus if you want to.
Actually, some monkey habitats, though, are wild-like. I mean, I work with monkeys, and our monkeys come from an island like we're tonight right now, from near the U.S.
They're wild. Yeah. Okay.
And they're room there, but they roam free in the island, and they're captured and transferred. So it's not black or white exactly.
Yeah. Okay. So in the lab, they're no longer a natural environment, right? So there's degrees to it. It's not black and white. There's some things which are obviously dramatically bad. There's some things which might not be perfect, but which are much better. Yeah.
And just when you talked about planning, is it just a legend that even a simple animal like ants plan somehow the food they put?
Well, I've never seen a serious paper claiming that ants plan.
Ants or insects or any kind of animal that are trying to gather food for the.
Well, we know that you know about bee dances, fish. So bees will go and find flowers with pollen, and when they come back to the hive, they will perform a dance, which actually contains information about where the food is, the direction of the dance signals the direction, the orientation of the food, and how much there is. They will dance faster if there's a lot of food and slower if there's less. So that might be some sort of planning, it might be instinctive, and there's a little bit of cultural evidence there, because the dances aren't identical between hives. So it's not 100% genetic. So maybe there is something there, but there's not a lot. Yes?
What is the natural kind of human? I mean, what's the natural environment for a human?
I think the natural environment for human is that we have multiple environments. Like we are defined by the massive range of different environments we can live in. So I don't think there's any way we can answer that question. I'm not sure it's a meaningful question.
I mean, when you compare, when you say that the monkeys are raised in non-natural environments, right? So there are really different kinds of environments for humans, and from each environment one gets a completely different set of skills and of perceptions, and so
maybe not completely different.
Well, not
you would certainly
completely,
get different. Certainly different. Yes.
What kind of human?
Okay. When I'm saying that the monkey or the chimpanzee was not in its natural environment, I'm saying there's some things which no monkey which has grown up wild would ever experience, like sort of being in a cage. I don't think we normally talk about experiments on humans in non-natural environments. But if I put it in a cage, if I put the human in a cage, that would be deeply non-natural for the human too.
Well, if you put a human in a small closed room without windows and turn off the light and make them sit in front of the computer and not move their head, it's also sort of not.
I think that's a fair point. I know that when Stanislas Dehaene in Paris does lots of imaging with human infants, and they spend a huge time habituating the infants to being a scanner before they ever go in the scanner. And even then, it sort of All these fMRI experiments are deeply, deeply unnatural because none of us is ever brought up in a big noisy tube. You know, so we have the problem. It's true for human experiments too. I suspect that for non-human animals it's even worse. We can't. It's much harder to prepare them. You know, it's hard. It's very hard with human infants too. And some aspects of experiments are naturally just unavoidably artificial. Most of us don't spend our time taking out computer things. But it's getting more common.
You're a psychology student, and you are.
Yeah,
hours and hours.
But are they human? Okay, they're special variety. Okay. Oh, sorry. Do you have one more question?
Just a small question. Regarding your hypothesis, your first hypothesis.
Yeah.
And in the second part of it, the first part was mentioning culture and cultural evolution.
Yeah.
And you said there's something special about. I don't know if you said special, but that humans have. Are evolving have cultural evolution that is faster than the decay of
yeah.
I was wondering how is it related to what you just said today, and you showed the example of the aboriginees.
Yeah.
I think, but is it something that is? I mean, does other species have cultural evolution that is just not fast enough? Or
I'm
do
going
they
to talk
not
about
evolve
that
at all?
later on, but it's very hard to trace because we have much less data for other species than we do for humans. But Bosch himself has done chimpanzee archaeology, so they found hammers and anvils for chimpanzees going back about 1,000 years for the nut cracking, and there's no difference between those and the ones we see today. That's also true for a lot of human stuff. If you look at the sort of early, we call them industries, sets of tools which humans had at the time of Homo erectus, you could take samples from sites which were a million years apart and you can't distinguish them. So this sort of fast evolution of the culture is relatively recent. You can certainly trace it to 70,000 years ago, maybe 100,000 years ago. Before that, it's probably there, but we can't really measure it.
So why saying that the difference is with humans having evolution that is fast enough, and not just saying that humans have evolution?
Of course, all animals have evolution.
Cultural.
I think humans have more cultural evolution, and I'm going to have the hypothesis that this is because of the social structures which humans created. And social structure, I don't mean sort of society in general. I mean the patterns of communication. Social network. Who communicates with who? And I'm going to show later on that the human patterns of social networks are deeply different from the patterns we find in other animals. So that's going to be my argument. I'm going to try and produce some arguments in favor of that. I've not got there yet. Okay, thank you very much. If any of you didn't get my mails, I think probably 2 or 3 people bounced, which means I copied your emails wrong. Can you come and I will write them on the computer in a way which I don't get wrong. Thank you very much. I'll see you tomorrow.